All right, I got two logarithm statements here that I wanted to look at because they're not as straightforward as the other ones. So the first thing I want to do is rewrite this as some exponential statement. 4 is my base, so I'm looking at 4 to some power will give me 8, right? The answer is not 1. 4 to the 1 is equal to 4. 4 to the 2, 4 to the 1 is equal to 4. 4 to the 2 is equal to 16. So my answer is going to be somewhere in between 1 and 2. All right. And if you're good with fractional exponents, this process will be pretty easy for you. It's like, you take the square root of 4, you get 2, and then 2 to the third power will give you 8. So it has something to do with a 2 and a 3. But the way that you can solve an equation like this, an exponential equation, sometimes, not always, but when there's a relationship between the base here and the right side, like if you can express them both as, a power of some number, like here, these are both powers of 2. So I'm going to rewrite the right side as 2 to the third. And then for the 4, I'll rewrite that as a 2 to the second. And all of that is raised to the x power. All right, this will allow us to solve this. All right, on the left-hand side, I've got a power to another power. So our exponent rule is to multiply those exponents. So it's just 2 to the 2x is equal to 2 to the third. And now at this point, we're kind of fortunate because the left and right side are just a power of 2, a base of 2. This is going to imply that these exponents must be equal to each other. So I can actually ignore the base of 2 now. So 2x is equal to 3. That means x is equal to 3/2. That would be our answer. And you probably guessed that from the very beginning. I told you, the answer has to be between 1 and 2. So you probably naturally guessed 1.5. Okay. Sometimes you can't just guess, though. All right, let's look at another one here. I've got 27 as my base, raised to some power is equal to 9. So 3 is going to be my common base between these two. If I look at the left-hand side, the 27, I could rewrite as 3 to the third. The 9 is equal to 3 to the second. This will be 3 to the 3x. All right, and now you can set these exponents equal to each other because the bases are now equivalent. 3x is equal to 2, so x is equal to 2/3. All right. So log base 27 of 9 is 2/3. All right, and what's going on here is, if you take 27, if you take the cubed root of it, okay, raise it to the 1/3 power, this will give you 3, and then 3 to the second power gives you 9. And that's what's going on here. That's the way that you can kind of do these types of equations without having to go through all this process. All right.